welcome you to this session. Today's class we are going to study which is very important. So matrices is one of the very simple topic, but mainly two things. One is cofactor, right? First day we studied. Using cofactor we did few sums. Then after the rank, in which the rank, finding rank using elementary transformation method, right? That's what more important. So today's class and next exercise also based on that only. So those are not thorough in that, I want you to study that thoroughly. Finding rank using elementary transformation. You know there are 3 elementary transformations. If you are thorough with that, some extra results we can do that, okay? We are going to study how to solve equation. Already solving simultaneous equations, you study 2 methods, right? One is matrix inversion method using matrix, another one using determinant or Cramer's rule. All these we studied. So today we are going to study another method, how to solve a system of equation using Gaussian elimination method. It is elimination method, so using rank only, okay, or they can say using rank method. Using matrix method, using determinant method, using rank method, another name Gaussian elimination method. It is used to solve simultaneous equations, okay. Straight away go for a sum. When you do the sum, I will explain to you how to find that, okay. Listen. Normally they give 3 equations. So here instead of 3 equations, what we are doing, a statement sum I have taken, okay. So using remainder theorem, you know what is remainder theorem, you have to study in the lower classes, right? Suppose a polynomial is given, p of x is a polynomial. When you divide by x minus 2, what's the remainder p of 2? When you divide by x plus 3, what's the remainder p of minus 3, okay? So here a polynomial is given, ax square plus bx plus c is divided by x plus 3, you will get a remainder 21. When you divide by x minus 5, you are getting a remainder 61. When you divide by x minus 1, you are getting a remainder 9. There are 3 unknowns, right? A, B and C. Find A, B, C using Gaussian elimination method. Method they specified, okay? So first you frame 3 equations. So framing 3 equations directly they give, that type I didn't do, because if you know this you can do that question easily, right? So how to frame the equation? This is a polynomial given. The given polynomial is p of x, ax square plus bx plus c. Okay, that's a polynomial. First one, we are dividing by x plus 3. What's the remainder? P of minus 3, right? P of minus 3 equal to 21. P of minus 3, 21. Meaning for x you put minus 3. For x you put minus 3. Minus 3 square, 9. So 9a minus 3b plus c equal to 21. Next we divide by x minus 5. X minus 5 means what's the remainder? P of 5, right? P of 5 is equal to 61. P of 5 equals 61. For x you put 5 and equate with 61. Third we divide by x minus 1. Dividing by x minus 1. So P of 1, right? P of 1 equal to 9. So P of 1 equal to 9, third equation. So 3 equations you are getting, we have to solve it. Gaussian elimination method. Now I'm going to explain what is Gaussian elimination method. It's a very simple thing. First you write matrix equation. That you know what is matrix equation? Ax equal to b type, right? Ax equal to b. X means unknowns. Here what are the unknowns? A, B, C. So we are writing A, B, C. Here write the coefficients. What are the coefficients? 9, minus 3, 1. Like that you write all the coefficients. Sign important. If a term is missing, you write 0. You check whether are they in the correct order. Everything you check. Because first part, see, while framing the equation, if you say make some mistake, totally it's wrong. So be very careful in this area. Okay. Now you write a matrix called augmented matrix. What is augmented matrix? You know, we write this is A, this is X, this is B. Once you know from equation, you are writing matrix equation. From here also you can write this. How? If you multiply row by column, you will get the value. 9a minus 3b plus c equal to 21, right? Like that you can write. But now augmented matrix means we denote it as AB. What is AB? You know, you write A. With that, the last column you attach this. 21, 61, 9. 21, 61, 9. This is the matrix equation Ax equal. This is A and this is B. AB means A and B together. AB. This is A. And after the third column, attach that B. What is that B here? This is B, right? A is this one and B is this one. So augmented matrix AB is this one. A then B. Now reduce it into echelon form. So how can you reduce to echelon form? First row, first element we want 1. So interchange first row and third row. Interchanging first row, third row, you will get this one. Once this is 1, you make these two zeros, right? You know the method. 25 minus 25, multiply by 25 and subtract. So R2 is R2 minus 25 R1. 9 minus 9, we won't make this 0. So R3 is R3 minus 9 R1. R3 is R3 minus 9. You will get this step, okay? Now, first row, first element 1, below that 0. Second row, second element 1. If not, if you are able to make 1, something common, you divide. Or if you can subtract or something, if you are able to make 1, if not, at least you make this as what? 0. So what I am doing here, here you can divide by what? You can divide it, right? You can divide by 4. And this you divide by 2. Minus is also there. So here we are dividing by minus 4. And here we are dividing by minus 2. So you are getting 5 here and 6 here. Here you are dividing by minus 4. So minus you are dividing. So everything become plus, right? Everything become plus. Also you are dividing by 4. You will get this step. Last row, third row, you are dividing by minus 2. Only minus 2 we are dividing. The reason is, you can divide by 4 also. We are dividing by only 2 so that you will get what? 6 here. Now what you can do? Otherwise, you can divide, 3 you cannot divide it. So now what you can do? 6 minus 5 is what? 1. 6 minus 5 is 1. Then you can interchange. So 6 minus 5. So R3 is R3 minus R2. Now we interchange these two. So you will get this number as what? 1. Okay. So interchanging, you are getting this step. Now I want to make this 0, right? 5 minus 5. This one already you studied. 5 minus 5. So R3 is R3 minus 5 R2. R3 is R3 minus 5 R2. You will get this step. Now it is in echelon form. Last row, if you want, you can make it as 1. 16 table, you can divide it, right? So dividing by 16, you will get this step. Up to this, you know, right? Now what you can do, write it as a matrix equation now. This is A and this is B, right? So corresponding equations are first row, if you multiply by x, y, z, you will get this one, right? From here you can write the corresponding equation. 1x plus 1y plus 1z equal to 9. But here x, y, z, instead of that what you have letters here? A, B, C. So A plus B plus C equal to 9. What is the second equation, can you say? 0A, leave it, plus B minus 2C equal to minus 11. P minus 2C equal to 11. Okay. What about the third one? 0A, 0B, leave it. 1C, C equal to 6, that's all. C equal to 6. C value, got it. Now back substitution. C equal to 6, you substitute here in the fifth equation. Instead of C, you put 6. 2 6 are 12. Minus 12, take that side, plus 12. So B equal to 1, you'll get. B equal to 1. Now B and C, got it, substitute the fourth equation, B and C is substitute, you will get A value also. So the answer A is 2, B is 1 and C is what? 6. That is what they asked to find. Okay, this is elimination method. Okay, using this method you can solve. Now let us see another question of the same type. A boy is walking along the path. A path is given, y equal to ax square plus bx plus c. Here again a statement sum. So I am doing a statement sum so that other sums you can do very easily. Already equation given, you can do that easily. Okay. So here frame the equation, then we do. A boy is walking along the path, this one, through the points 1, 2, 3. He wants to meet his friend. His friend is in which point? 760. Will he meet his friend? Use Gaussian elimination method. Listen here. This is a curve. Y equal to ax square plus bx plus c. It is a parabola, right? In 10th standard you study, draw the graph. Y equal to 7x square plus something like that. Okay. It is a parabola, some curve like this. Okay. So what we do, there are three unknowns. What are the three unknowns? A, B, C. You find that A, B, C first. Please listen, I will tell you the method. First, how to find, we will see that. We find A, B, C, substitute. You will get the equation. Now, this is the path of his route, right? How he is going. Now, in that way, whether he is meeting his friend's door number, what is the number? 760. What do you do? In that equation, you substitute 760. For x you put 7. For x you put 7. Check whether you are getting y value as what? 60. If you get y value 60, you say yes, he will meet his friend. If not, you say he won't meet his friend. Okay. Now listen. We want three equations. For that, make use of these points one by one. So this is the given equation y equal to ax square plus bx plus c. This curve passes through minus 6 comma 5. So for x you put minus 6, y you put 8, y you put 8. So minus 6, 8. For x you put minus 6, so minus 6 square, 36a, right? Like that you substitute. And y value 8, first equation. Second point, minus 2, minus 12. It passes through minus 2, minus 12. For x you put minus 2. For wherever x comes you put minus 2 and y you put minus 12. You will get the second equation. Third equation, 3, 8. You will get the third equation. Three equations, you got it like previous question. Here also the unknowns are A, B, C. First you write matrix equation, Ax equal to B. You know what is A, what is B. You can write the augmented matrix. What is augmented matrix? A, B, right? First you write A, attach B. After a matrix equation you write first, okay? Then augmented matrix, A, B. A you write, coefficients you write 36 minus 6, 1. 4 minus 2, 1. 9, 3, 1. Last column, attach these values. Reduce it into echelon form. First row, first element, we want to get 1. 1 is not here, you can't, no other ones here, you cannot interchange. Then how to do? There are different methods, depends on the situation you have to do. One method is, can you find some method here? 36, 9 is here. If you multiply by 2, 4 2s are 8. Then 9 minus 8. You will get 1, then you interchange. That is one method. Another method, it is not very particular to make 1. Below that you make zeros. So what you can do, here 36, you can make it as 36. Multiply by 9. You can multiply by 4, 36. So then 36 minus 36, 0. 36 minus 36, 0. You can do in any way. What I am doing, I am making this as 36. So multiplying by 9 and third row you multiply by 4. Now 36, first row I am leaving. 36 minus 36. So R2 is R2 minus R1. So it separate everything. R3 is R3 minus R1. 36. So we want to make these two numbers as what? Zeros. Now here 1, here 0. Even if it is not 1, you make this number as what? 0. So minus 6 plus 6 you make. Take 2 outside. You divide by 2. Here you divide by 3. Divide by second row, divide by 2, third row, divide by 3. So minus 6 plus 6. So now making 0 is easy, right? Add these two. First row write as it is, second row write as it is. Third row is third row plus second row. 6 minus 6, 0. Third row is there. So you are getting like this, okay? It is in echelon form. Now you can write matrix equation. This into ABC. Here the unknowns are what? ABC equal to this. So the corresponding equation. Can you tell me what's the first equation? Here also if you want you can make it as 1. You can divide by 5 because it's divisible, right? If you want you can divide. So 1 minus 10 or even leave like this. First equation 36a minus 6b plus c equal to 8. Second 0a, leave it, minus 6b plus 4c equal to minus 58. And the third one 0a, 0b, leave it, 5c equal to minus 50. 5c is equal to minus 50. 5c is equal to minus 50. So c is equal to minus 50 by 5. Minus 50 by 5 minus 10. C value got it. That C value is substitute here. You can find B. That C and B is substitute here. You will get A also. After getting A, B, C, don't stop there. You substitute in the polynomial. One polynomial given, right? So in that polynomial, you substitute the values. You are getting A value 1, B value 3, C value minus 10. Okay, that values is substitute. You are getting the polynomial. Don't stop here. That is not the final answer. What they asked, this is his path. His path is a parabola. You got the equation. Now we want to know whether he will meet his friend. His friend is in which point? You are remembering? 760, right? 760. So what you do now, put x equal to 7 and find out y value. You put x equal to 7, 7 square, 49, 3 into 7, 21, minus 10, 21 minus 10, minus 21 minus 11, 49 plus 11, right? He'll meet, right? You are getting 60. What's the point given? 760. When you put x equals 7, you are getting 60. So what is your answer? The boy will meet his friend. Okay. So like that, some applications, some solved question, direct question. They will give 3 equation. You solve it, find A, B, C and stop there. Okay. So here I have taken 2 statement sums. So you can do the other sums in that this exercise. It's a very simple exercise. Okay. Just you can practice other questions. You can do that. Now we go for the next one. Very important thing. Consistency. Consistency. What is consistent, you know? Already you studied consistency. There are 2 things. One is consistent, another one inconsistent. Consistent and inconsistent. The meaning of consistent, solution exists. Solution exists. Inconsistent means solution does not exist. Graphical method you studied in the lower classes. When you draw the graph, sometimes 2 graphs intersect, right? They intersect at one point. That we say consistent. It has unique solution, one solution. Sometimes both the graphs lie in the same line. One line, another curve along the line. So how many common points? All the points are common points. Common points are called solutions. In the first case, 2 lines are intersecting at one point. So there is one solution. Another case, both the lines are coinciding. So all the points are common points. So solutions are there. In the first case, there is only one common point. Here there are many common points. So in the first case, there is one solution. In the second case, infinite number of solutions. Both are consistent. What's the meaning of consistent? Solution exists. Solution exists. There are 2 types. One is unique solution. Another one, infinite number of solutions. And another thing, inconsistent, meaning no solution. No solution. In the graphical method, sometimes when you draw the graph, one line, another line parallel to that, it won't intersect. Then there is no common point. We say there is no solution, right? So already studied lower classes. So consistent, inconsistent. What's the meaning of consistent? Solution exists. Inconsistent, no solution. Solution exists. There are 2 types. What are the 2 types? Unique solution or infinitely many solution. Okay, so there are 2 cases. Now, then in 10th standard also you studied, I think, A1 by A2 not equal to, right, B1 by B2 unique solution. Yes, you studied that method also. There are 2 methods you studied, but here using matrix method, how to do. Again, we are going to use rank elimination method only. That is the reason I said first result, it's very, very important. Reducing into echelon form. Practice well, then it will be very, very easy for you. Okay. So now listen here. Some names given. Roach-Capli's method. So method what we follow here. So you know augmented matrix, right? Just now we studied. AB is called augmented matrix. How to check? You write the augmented matrix AB. From that you can find rank of AB and rank of A. Already you studied. AB means first you write A, attach B, reduce it into echelon form. The whole thing gives rank of AB. Rank of A, no need to find separately. In that echelon form, just to hide the last column, because last column belongs to B. A, B, right? Last column belongs to B. Hide that one and see the remaining, how many non-zero rows, you can find rank of A also. You find rank of AB is the whole thing. You find the rank. Rank of A means leave the last column, the other 3 by 3 alone you check. So at a time, you can find rank of AB and rank of A. Using that only, we are going to say whether it is consistent or inconsistent. There are some rules, but take it, it's a very simple method you can remember. Okay. Find both the ranks, rank of AB and rank of A. When the ranks are not equal, you say inconsistent. When the ranks are not equal, rank of AB not equal to rank of A. Suppose here 3, here 2. Or here 2, here 1. They are not equal. We say the system is inconsistent. The meaning of inconsistent is what? No solution. Then when the ranks are equal, rank of AB and rank of A are equal, we say it is consistent. When the ranks can be equal, 3, 3 or 2, 2 or 1, 1. In all the cases, we say it is consistent unique a solution exists. Consistent solution exists. But in consistent, I said there are two cases. Unique solution or infinitely many solutions. So up to this, hope you understood. Just try to understand step by step. Once you understood the concepts, you can do the sums very easily. Write in echelon form. First you take the augmented matrix, reduce it into echelon form. You identify rank of AB and rank of A. When the ranks are different, when the ranks are not equal, just you say inconsistent, no solution. When the ranks are equal, consistent. But now I am going to teach you how to identify whether it has unique solution or infinitely many solution. Okay. Assume there are three unknowns. Suppose there are three unknowns. Rank of AB equal to rank of A equal to 3. Both are 3, 3. Suppose there are three unknowns. 3, 3 equal to, they are equal and equal to number of unknowns. Then we say consistent, it has unique solution. First I said when the ranks are equal, consistent. Consistent means it may have unique solution or infinite number of solutions. But now, how to identify unique solution is studied. It must be equal to, not only equal, but it must be equal to number of unknowns. Equal means it can be 3, 3, 2, 2, 1, 1. In all the cases, equal only, right? But equal to number of unknowns. If the number of unknowns are 3, that is in the question X, Y, Z or A, B, C. If there are 3 unknowns, rank of AB is 3, rank of A 3, 3, 3, then this comes consistent unique solution. Then in the other cases, 2, 2 or 1, 1, consistent but infinitely many solutions. Rank of AB equal to rank of A are equal but less than number of unknown. That means it may be 2, 2 or 1, 1 in the case of 3 by 3. Then we say consistent, but which type consistency? Infinitely many solutions. Then how to solve, I will teach you. But before that, we will see one more time. Consistency, there are two things, consistent, inconsistent. What's the meaning of consistent? Solution exists. Inconsistent, there is no solution. Solution exists, there are two types. It may have unique solution or it may have infinitely many solutions. What's the rule? Find the rank of AB and rank of A. If they are not equal, just to say inconsistent, no solution. If they are equal, it may be unique or infinite. Count the number of unknowns. Suppose the unknowns are 3, then you check for 3, 3. If it is 3, 3, unique solution. Less than that, that is 2, 2, 1, 1, we say infinitely many solutions. Okay. Now how to solve? 3 by 3. Suppose ranks are equal but 2. That means the last row fully 0. Last row fully 0, you will get only 2 equations. The system reduced to 2 equations. Consistent, infinitely many solution, system reduced to 2 equations because rank is 2 means last row, third row fully 0. Only 2 equations you get, but there are 3 unknowns. You have to give a substitution, put Z equal to T and do that. Either T or K, any value you can give. But there is another case, the ranks may be 1, 1, right? If it is 2, 2, okay. If it is 1, 1, again it is less than number of unknown, consistent, infinitely many solution. But listen, when we say the rank is 1 means second row fully 0, third row also fully 0, you will get only 1 equation. But there are 3 unknowns, you will get only 1 equation. System reduced to a single equation. Single equation means you give 2 substitution because you want 3 values, right? You give 2 substitution, put y equal to s and y equal to s and z equal to t. Okay, any 2 values you give 2 parameters and you find the other one. Okay, when you do the sum, you can understand better. Okay, now we go to the next exercise, how to solve. Test for consistency using rank method. Test for consistency. If it is inconsistent, you cannot solve it. Stop there. Otherwise, you have to solve it. Okay. So, 3 equations given here. First, you check, are they given in the correct form? X, Y, Z constants in the right side, given in the correct form. You can write the matrix equation Ax equal to B, Ax equal to B. Then you can write, that also a step you write. After that, you write the augmented matrix. What is augmented matrix? A attach B also. A is this one, 2, 2, 1, 1 minus 1, 1, 3, 1, 2. Attach B. What is that? 5, 1, 4. Reduce it into echelon form. So the whole thing is AB. A means leaving the last column, right? So that is A. So at a time you can find rank of AB and rank of A. So columns you should not change. That is why we are using only row. Then only at a time you can find rank of AB and rank of A. First row, first element 1, very simple, interchange these two, right? Interchanging second row, first row and second row. Interchanging 2 rows, you are getting 1 here. Make these two zeros, easily you can do now, 2 minus 2. So R2 is R2 minus 2 R1, 3 minus 3. So you are getting these two. Now I want to get 1 here or at least 0. Making 0 is easy, 4 minus 4. So R3 is R3 minus R2. So you get this step. Now look here. Now here you cannot make 1, right? So you stop here. What is rank of AB? Rank of AB means the whole thing you see, the whole thing is AB. Number of non-zero rows, 1, 2, 3. Because one element is here. Rank of AB is 3. Rank of AB is 3. What is rank of A? Leave the last column. You take only this part. How many last row fully 0 now, right? 1, 2 only. Here fully 0. So rank of AB is 3, but rank of A is only 2. Ranks are not equal. When the ranks are not equal, what is your answer? Inconsistent. There is no solution. Okay. So rank of AB is 3. Rank of A is only 2. So ranks are not equal. So we say the given system is inconsistent. There is no solution. We go for the next question. First equation, second, third. 3 equations given. Are they in the correct form? X, Y, Z constants, right side, correct form. So you can write the matrix equation Ax equal to B. This is what you have to write. Ax equal to B. Here unknowns. If they are ABC, you write ABC. X, Y, Z, you write. Sometimes X1, Y1, Z1 like that they give. Or X1, X2, X3. You write whatever they give unknowns, you write here. Now augmented matrix AB, A, attach B. First row, first element already 1. Make it as 0, 2 minus 2. What step you write? R2 is R2 minus 2R1. Make it as 0, 4 minus 4, right? So you will get this step. First row, first element 1, below that 0. Here 1 or make this 0. Making 0 is easy, 3 minus 3, right? Making 1 also easy in this question. Why? Because second row you can divide by 3. Right? If you want, you can do that also. Divide by 3, you will get like this. Then you make it a 0, 3 minus 3. Multiply by 3 and subtract it. It is an echelon. Here also, see, you can make it as 1. This sum easily you can do that, right? Minus 7 you can divide. So it will become 1, 1. It is an echelon form now. What is rank of AB? 1, 2, 3. Rank of AB is 3. What is rank of A? Leave the last column. Leave the last column. How many non-zero rows? 1, 2, 3. Here one number is there. So rank of AB equal to rank of A equal to 3. Number of unknowns, right? Equal to number of unknowns. So it is consistent, but which type consistency? Unique solution. Because 3, 3. Total number of unknowns 3. Rank of AB is 3. Rank of A also 3. So now how to solve it? You write it into matrix equation. Once again, Ax equal to B. You can frame the corresponding equations now. How can you frame the equation? Multiply by x, y, z, first row, first column, right? And these are your answers. So, x minus 1y plus 2z equal to 2. Again, x, 1x minus y, minus 1 into y. X minus y plus 2z equal to 2. Second equation, 0x, leave it. Y plus 0z equal to 1. So, directly you are getting y equal to 1. Third one, 0x, 0y, 1z equal to 1. So, z equal to 1, right? So, these are the 3 equations you are getting. Y equal to 1 and z equal to 1. That y equal to 1 and z equal to 1 is substitute, you will get x value also. So, you are getting x value 1, y value 1, z value also 1, and that is the solution. So, ranks are equal to number of unknowns. So, we say consistent, unique solution. And the equivalent equations, how we got the equivalent equations, you know, how we got these equivalent equations. See once again the equivalent equations from here. From here you are writing the equivalent equations, right? X minus y plus 2z equal to 2. 0x plus y, 1y plus 0z equal to 1. So directly you are getting y equal to 1 and z equal to 1. So you are getting all the three values, and that is what they asked to find here, right? Now we go for the next question. Three equations given, it is in the correct form. Matrix equation, augmented matrix, A, B. A means the coefficients you write, attached constants, B, 2, 1, 5. Reduce it in echelon form. This one you bring it here, interchanging first row and second row. So that is the first step you do. Now make these two numbers 0, 3 minus 3, right? 7 minus 7. What step you write, you know how to do that. So you will get these two numbers 0. Now here 1, here 0. But making 0 is easy. But before that you can make it as 10, right? Dividing by 2. If you divide by 2, you will get 10 here. Now 10 minus 10, you will get what? 0. The step you write. Now fully 0. It is in echelon form. What is rank of AB? 2. What is rank of A? That also 2. 2 non-zero rows, right? Ranks are equal, so consistent. But which type consistency? Infinitely many, so because less than number of unknowns. 3, 3, then only it has unique solution. Here 2, 2, the ranks are equal, so consistent. But less than number of unknown, so less than number of unknowns, so consistent. But which type consistency? It has infinitely many solution. How to solve it? Please listen. Corresponding matrix equation. What's the matrix equation? Tell me. X minus 3y plus 2z equal to 1. First equation. Second equation, 0x, leave it. 10y minus 5z equal to minus 1. Third, fully 0. So you are getting only two equations you are getting, right? You are getting only two equations. There are three unknowns, but only two equations. You cannot solve it. So that is the reason system reduced to two equations. We give a substitution, put z equal to t. Normally we put z equal to t. Any one variable you can give, but normally we put z equal to t or k. Put z equal to t. Back substitution. That z value substitute here. Z equal to t. You give here z value t. So minus 5t take that side plus 5t, right? Plus 5t. And y equal to 5t minus 1 by 10, right? Y value. Now y value and z value, you know, y value is this one and z value, you know, both the values substitute in the first equation, y and z you substitute, you can find what? X also. Calculation, simple calculation, take LCM and you can do that. Finally you write x value, y value and z value. Here ranks are 2 and 2. Only two equations. Two equations to solve. There are three unknowns, so put z equal to k and do, right? See another question. Three unknowns, three equations given, everything is given in the correct form. So matrix equation Ax equal to B, write this right away. I am writing the augmented matrix AB, A attach B. First row, first element I want to get 1. It is not 1, not easy to get. But what is common here? 3, divide by 3. What is common here? 2, divide by 2. Second row, divide by 3. Third row, divide. See, all good numbers, right? Everything same. So now you can make it a 0, 2 minus 2. Make it a 0, 2 minus 2. First row write as it is. Second row is second row minus first row. Third row is third row minus first row. You will get a beautiful matrix like this. It is in echelon form. What is rank of AB? 1. What is rank of A? That also 1. Here fully zeros, right? Ranks are equal, so consistent. Ranks are equal, so consistent. Which type consistency? Since it is less than number of unknowns. How many unknowns are there? 3 unknowns. There are 3 unknowns, x, y, z. Here we are getting 1 and 1. So rank of AB equal to rank of A equal to 1, but less than number of unknowns. So consistent. Which type consistency? Infinitely many solution. How can you solve it? System reduced to a single equation here. Write the corresponding equation 2x minus y plus z equal to 2. Other equations are all zeros, right? You are getting only one equation. This is the only one equation you are getting, right? Other two you are getting zeros. So give two substitutions you give. Put y equal to s and z equal to t. The previous question system reduced to two equations, put last letter z equal to t. But here only one equation, there are 3 unknowns. So 2 variables you give values, assign some values. Put y equal to s and z equal to t. Y equal to s and z equal to t. Take it to the right side. 2x you will get, divide by 2 you will get x value, right? So like that you can find x value. So the solution x value, y value, z value, and s and t belongs to R, that is some real numbers, okay? Now another question you see. Find the value of k. Find the value of k for, there is an unknown. What's unknown here? K. They asked to find k value. 3 equations given. 1, 2, 3. In all the 3 equations, k is there, right? So find the value of k so that the system has no solution, unique solution, infinitely many solutions. So k is an unknown. What value should be given to k, or what value should not be given to k so that the system has no solution, so that the system has unique solution, so that the system has infinitely many solutions. Don't worry, we try to do the usual method, everything given correctly, right? So you write the augmented matrix. So all the 3 equations arranged in order, matrix equation. From this you can find the augmented matrix. So what's the augmented matrix? AB, right? A attach B. Now listen carefully. First row, first element we want to get 1. But you can see 2 1s, right? If there is 1 1, no problem. We take interchange that. When there are 2 1s, you have a doubt whether to interchange first row and second row or first row and third row. Normally we interchange the nearby, right? But if we interchange these 2, the calculation I checked not that much easy. So in this question, interchange first row and third row. But this is also correct only. We want to get 1 only. But if it is familiar, already we did. If you want, you can try that one. Okay, you may find little difficult with the calculation. So this question you mark it. Okay, when you go for the examination, these things you have to remember. So if they ask the same question, you have to be very careful. Instead of, there are 2 options, right? There are 2. Any one can be interchanged. So in this question, we are interchanging first row and third row. Okay, so mark such things so that it will be useful for you for the exam time. Okay, first row and third row we are interchanging. So you can get this step. Now first row, first element 1. We want to make these 2 zeros, right? So this 1 minus 1. So what do you do? Second row is second row minus first row. 1 minus 1, 0. Minus 2k minus plus, right? Minus 2k plus 2. 1 minus k. Minus 1, minus 2, minus 1, minus 3. But this one, how to make 0? K minus k. That's all. If it is 7, what do you say? 7 minus 7. Same thing, k. Multiply by k and subtract. You may not be able to simplify, that's all. Multiply by k and subtract. K minus k. 0. 2 minus plus. Up 2 plus 2k. Here minus 2 plus 2k. Minus 2 plus 2k. Multiply by k and subtract. 1 minus k into k. K square. 1 minus k. Multiply by k and subtract. K minus k. Minus 2 plus 2k. Minus 2 plus 2k. 1 minus k square. 1 minus k. Are you able to understand? Okay. First row, first element 1. Below that 0. Make it as 1 or make it as 0. Making 0 is easy because 2 minus 2 cancel. Minus 2k plus 2k. So what I am going to do are adding these 2. First row, second row you write as it is. Third row is third row plus second row. Third row is third row plus second row. So fully you are getting 0. And this one you factorize. It's a trinomial. Sum is minus 1, product is minus 2. You factorize it. You know how to factorize it. So you are getting like this. Up to this you can do. Now only the 3 cases. What they asked here, there are 3 subdivisions. First part they asked what value should be given so that the system has no solution. No solution means, first they asked for no solution, second they asked unique solution, third they asked infinitely many solutions, right? All the 3. Okay, we check one by one. Suppose I put, there are 2 factors, 1 minus k and k plus 2. Suppose you put k plus 2 0. K plus 2 0. K plus 2 0 means you put k is equal to minus 2. Suppose wherever x comes you put minus 2. What happens, you know, when you put minus 2 plus 2 0, minus 2 plus 2 0. This row fully 0. Last row fully 0. You will get only 2 rows. So rank of AB is 2. Rank of A also 2. So less than, they are equal, so consistent, less than number of unknown, so it has infinitely many solution, and that is the answer for the third part. Third part they asked infinitely many solution. When you put k equal to minus 2, because see the factor, when you put k equal to minus 2, this term fully 0, this also fully 0, already here 2 0, so last row fully 0. Here and all you have some number, right? So 2 rows you will have numbers, so rank of AB is 2, rank of A also 2, so consistent infinitely many solution. No need to solve that, only thing k value find out. Okay, that is one case. Actually that is the answer for the third one. Suppose k is equal, another factor is 1 minus k. You put, how can you make this a 0? Put k equal to 1, right? Next we give that substitution when you put k equal to 1. When you put k equal to 1. When you put k equal to 1, 1 minus 1, 0. So this fully 0. Already here 0, 0, this also 0. It won't be 0. When you put k equal to 1, it will be minus 3, right? It is not 0. This is 0. K equal to 1, this is 0. K equal to 1, this is 0. So up to all these 0, here and only you have two numbers. Use this minus this, subtract. So rank of AB will be 2, rank of A will be 1 only. Because this part fully 0. 0, 0, 0, 0, 0, 0. So leave the last column. Only one row is there. So rank of A will be 1. But rank of AB you will get, these two numbers are zeros. These three numbers here, these three fully 0. Only here you have some numbers. One non-zero number, below that you will make 0, right? So subtract will make it 0. So only 2 rows you will get. So rank of AB is 2, rank of A is 1. So ranks are not equal, that means inconsistent, there is no solution. That is the answer for the first case. So for the first case, k equal to 1. Third case, k equal to minus 2. And one more thing, unique solution. Unique solution means ranks must be 3. Rank of AB 3. 3 means you must have a number here. So none of them must be 0. None of them should become 0. So k don't give 1, k don't give minus 2. So don't put k equal to, so what you give, k not equal to minus 2 and k not equal to 1, then you will have a number here. You will have a number. If we have a number here, don't worry about other things and all. If you have a number, rank of AB is 3, rank of A also 3, then ranks are equal and equal to number of unknown. So these are the three cases. First I explained when put k equal to 1, these are the answers you are getting. Ranks are not equal, so inconsistent, no solution. Unique solution just now I explained, none of them is 0. So k not equal to 1, k not equal to minus 2. So ranks are 3 you are getting. So number of unknown, unique solution. And the last case that I explained first, right? When you put k equal to minus 2, one row fully 0. So rank of AB, rank of A 2. Less than number of unknowns. So consistent, infinitely many solutions. Okay. So these cases don't try to mug up. So with the step you have to try to understand and do, it will be easy for you. Okay. I'll explain one more question of the same type. Now two unknowns. Investigate the values of lambda and mu. This is the last question. Listen. Investigate the values of lambda and mu. Three equations given, 1, 2, 3, three equations, they given in correct form. First equation, second equation, no unknowns. In the previous question, k in 3 places, but I asked you to remember one step, right? First step, interchanging first row and third row, right? To make the first element 1. Okay, listen this sum. There are two unknowns here. First you write, so these are the 3 cases. Here again 3 cases. What value should be given to lambda and mu so that the system has no solution, unique solution, infinite number of solutions. So first you write the matrix equation Ax equal to B. A is the unknowns, coefficients you write. Unknowns x, y, z. Constants 9, 8, mu. Augmented matrix you write next, right? Augmented matrix. Now, first row, first element 1. How can you make it as 1? How can you make this number 1? 7 is here. Either you make it as 6. Multiply by 3, then 7 minus 6. Or you make it as 8. Multiply by 4. First row you multiply by 4, you will get 8. 8 minus 7, 1. Okay, so you can do in that way. First row we multiply by what? 4, so that 8. Then 8 minus 7, R1 minus R2, you are getting 1. So that method you can do. Now these two numbers zeros, 7 minus 7, 2 minus 2. So that steps you know, you are getting like this. Now, this one I want to make 1 and this 0. Even if you're not making 1, this you must make 0. So minus 15, this also you make 15. You can divide by 4, right? This row you can divide by 4. Better you divide minus 4. If you divide by minus 4 plus 15 you'll get, right? If you divide by minus 4 plus 15. Minus 15 plus 15 you will get what? 0. So this step you got it. Okay, it is in echelon form. Now please listen here. One speciality here. You cannot make the previous question k appeared in many places. But here your work confined only in these 2 places. You cannot make any change these numbers, right? By any substitute, you cannot make any change. Only these 2 you can make change. Here they asked 3 cases. First they asked no solution. First they asked what? No solution. When we say no solution, ranks are different. Rank of AB 3, rank of A 2. Or rank of AB 2, rank of A 1. Here 2 is definitely you cannot make any change. Only here you can make some change. So 3, 2 you try. Suppose I am making this number 0. If I make this number 0, rank of A will be 2. Because last row fully 0, right? Rank of A 2. And this is not equal 0. This is not equal 0 and this is 0. This is not equal 0 means you will have a number here. This is 0. You make this 0 and have a number here. Then rank of AB will be 3. Because 0, 0, 0, you will have a number here. Rank of AB is 3. Rank of A will be only 2. Because these 3 numbers become 0. So make this 0, this not equal 0. So what step you write, tell me? So here lambda equal to 5. Lambda equal to 5. Mu not equal to 9. Lambda equal to 5. Lambda equal to 5 and mu not equal to 9. Rank of AB 3. Rank of A 2. So ranks are not equal. Ranks are not equal means what you say? Inconsistent. There is no solution. Second case they asked unique solution, right? Listen, for unique solution. Unique solution means rank must be what? 3. 3, 3. Already I said this part you cannot make any change. Rank must be 3. Rank of AB 3, rank of A also 3. Rank of A3 means, leave this one, rank 3 means you must have a number here. When will you have a number here? Lambda not equal to 5, right? Lambda not equal to 5. So what value you have to give? Lambda not equal to 5. What should be mu? This is very, very important, listen. Lambda not equal to 5, so you will have a number here, right? You will have a number here. Then rank of A is 3. What will be rank of A? For that what value should be given to mu? You give any value for mu because already a number is here, right? We are giving lambda not equal to 5. You have a number here. Then what is rank of AB? 1, 2, 3. We are not bothered about this. Whether it is 0 or not equal to 0, it is not going to affect because we have a number here. If we have a number here, rank of AB is 3. Rank of A also 3. If we have a number, we are not bothered about this. This mu can take any value. Mu is equal to 9 or mu not equal to 9, doesn't matter. So you write mu belongs to R, we write. Okay, so this step very important. This sum also you mark it because previous sum I said K, we K11, we interchange first row and third row. Same way this sum, the second case, unique solution. Now investigate the values for lambda and mu they asked, okay. So lambda not equal to 5. When you put lambda not equal to 5, you have a number here. Once you get a number here, don't worry about this. This is 0 or not 0, it is not going to affect the rank of AB. So mu can take any value, you say mu belongs to R. Now the third case, infinitely many solution. When we say infinitely many solution, 3, 3 should not come. Either 2, 2 or 1, 1. Here 1, 1 not possible because second row also we have elements. Make it as 2, 2. That is you make the last row fully 0. Last row fully 0 means put lambda equal to 5 and mu equal to 9. Lambda equal to 5, mu equal to 9 so that the last row fully 0. Last row fully 0 means rank of AB is 2, rank of A also 2. So ranks are equal but less than number of unknown, right? 2, 2 less than number of unknown. So you know the system has infinitely many solutions. 5 and 9, ranks are 2 less than number of unknown. So look once again, lambda equal to 5, mu not equal to 9, I explained. Second part, lambda not equal to 5, mu belongs to R. Mu is arbitrary, you can say. Mu can take any value. So this part you have to be very careful. Normally students make mistake here, okay. So consistent unique solution. And the last one, lambda, we are making the last row 0. So for that, lambda 5 mu 9, the last row fully 0. So the ranks are 2. They are equal but less than number of unknown. So consistent infinitely many solutions. So today we studied 2 exercises, but both are very simple thing. But only thing, as I said earlier, you must know how to reduce it into echelon form. So practice that, you can do that. See you in the next class.